today's lecture. Uh, to summarize what we have seen in the previous turn is fork, where we have seen that fork creates a duplicate of the calling process, and the result of the fork is two processes. One is parent, which is already running, which has called the fork, and child, and then both continue execution from the same point on. Then we have seen exit and wait. These are required for the orderly process termination. Uh, when parent call fork, it waits for child to finish the execution. At the same time, when child finishes, it issues exit, and these exit and wait work together to achieve orderly process termination. But if you can see the way fork was working, the child process is exact replica of the parent process. And if in this way everything keeps on happening, then it would be very difficult to create new processes. Every process will become init process because init is the master parent. Init is the Brahma of all the processes. So init forks, then another init that will fork another init. Every time only init would be there. So how to change the behavior or how to change the outcome or code part of the process after fork? That is what we are going to see today. We'll be seeing system calls from exec family. Now, in child or in any process, if you are using exec, there are variations of exec, exec v, exec l, exec lp, exec ve. So that's not a major concern right now. So if we are using system calls of exec family, now you can execute a program, and that as soon as you call exec system call, the process image, whatever is created after fork, is destroyed and a new process image is created. I'm only telling you about the primitive fork functionality and exec functionality. What actually is happening in nowadays Linux and Unix, that we will be seeing a bit later when I'll tell you about copy on write, COW. But for now, what you can understand that fork creates a exact image of the parent process, and then if you want to change the behavior of the child process, you can issue exec, and exec can transform the child process into a new process. There are various versions of exec, like if you see exec v, here you have to give the full path of the program to be executed, which can change the text area of the child process. And if that program requires some arguments, then you can give as a second argument of this exec v command. Now let's see how exec works in function. As we have seen, after fork, there are two processes with PID 25 and PID 26, and both are sharing everything. Now, in parent code, parent is waiting for child PID, means parent is specifying that I will wait for this particular child, and here you can give argument as child PID in wait system call. So parent is waiting for child PID or child to exit. What is happening in child? Let's see. In child, when child return value of fork is 0, the fork is returning value in CPID. When CPID is equal to 0, means it is a child process, and in child process you are issuing this system call exec v. Now this is the system call. As soon as this line will be executed, the control will be passed to the kernel. And in this system call, as we have seen, the first argument you can give the path of the program to be executed. Suppose we wanted to execute ls here. So we will give the path of the executable, say /bin/ls. Now what will happen as soon as this exec v is executed, means control will be transferred to the kernel code. The image of PID 26 process will be destroyed, and a new process image will be constructed from the executable file. Now, in this manner, exec can be utilized to change the behavior of the child process. Otherwise, child process would be behaving as exact replica of the parent process. Now, this is just a small thing about exec. How to use different flavors of exec, different variations of exec, that I'll give you as a reading assignment. So let me explain it again. If we go back, fork creates two processes. Child exits, parent waits. For orderly termination, we have the combination of wait and exit. If you want to wait for a specific child, you can give the child PID, that okay, I'm waiting for this particular child. I've given you two commands also. Get PID returns the ID of calling process, and get PPID can give you the ID of the parent process. So fork, exit, and wait to create new process. And afterwards, if you want to change the flavor or behavior of a new process, you can use exec. Any questions from anybody here? Any questions from anybody? Abhigyan, it's clear?
Yes, sir.
Okay. We'll see a demonstrative example today also of fork and exec and how things are happening. Don't worry. Now, after destroying the image of child process which was created by fork, a new image will be created, and that new image will be of executable ls, because we have given the path of ls here. Now what will happen? This new image will start executing the ls code, and finally this will exit, and this exit is collected by this wait, and then you can stop the processing. The parent is also dying, and child is also dying. Now, if anybody can answer my one question, suppose I'm writing ls here. So what is happening behind the scene? Now anybody can answer this? Yes? Suppose I ask Sneha Singh.
Yes, sir.
So if I'm writing ls on command prompt, or for that sake any other command, what is happening behind
Sir,
the scene?
Alice, like what I understood, that Alice would be a child process for
Of
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 the of the operating system.
of the operating system. Yes, anybody else? Say Abhinav Anand.
Yes, sir. So the ls command will be a child process of the parent process init.
Parent process init. Init is very far behind. The system is already booted, no?
Yes,
I'm
sir.
running a terminal.
Okay, so the parent process will be shell here. The
Pa-
shell process
Parent process will be
shell here.
shell here.
Yes, sir.
Okay. So let's see how actually shell works. So suppose you are working on a bash, and if you want to run any command, so here shell is going to be the parent process. And suppose you have written command ls minus l. So in the code of shell, there is a parser. So parser will parse the command. And now shell will issue a fork. So when shell will issue a fork, a new shell will be created because parent is shell, another process will also be a shell. Now parent shell will issue wait. Parent shell will issue wait. And in child shell, which has been created by forking, will issue exec command. Exec with the path of ls minus l. With the path of ls rather, minus l will be taken care as an argument. And then ls will execute, ls will exit, fine. Return status will be sent to parent, and again parent is working. So this is how your command line interpreter or shell works. Everybody got this point? Sneha, you understood this now?
Yes, sir. Now I understood.
Okay.
Yes, sir.
Abhigyan, any issues?
No, sir.
Okay. So there are variations of exec, the way you provide arguments. In some variation, you can provide the path. In some variation, you can provide the executable name which you want to execute that has been taken care by your environment variables. So there are variations, and this is what I want you to read by yourself. Different variation of exec, exec v, exec vp, exec l, and exec lp. Now there is a another interesting command or a system call known as system call. You can use this system call which can combine fork, wait, exec all in one. So it is a combination of fork, wait, obviously exec and exit all in one. If you want to write a C program where you want to use fork, wait, exit, instead of doing that, you can directly write system call, and that will do the work for you. So in this way, at a system call level, how to create a process, we can create a process, we can change the flavor of the process. This is done. Now what we are going to do today is we are going to see some interesting thing which normally you might have done in your shell programming course. Now suppose if I ask this question to maybe Abhigyan. Abhigyan, see the terminal properly. Suppose I say that ls, what is this symbol? Abhigyan?
Uh, I don't know, sir. This.
Anybody can tell what this command is going to do? Or what is happening here? Whatever I have
Sir,
written, yeah.
it will count the number of words of the output of ls.
So what is happening actually? What is this?
Sir, pipelining.
Pipe. So output of ls is going to
WC.
input of wc. That's what is happening. Obviously it will do this. So if I see ls, so there are 1, 2, 3, 4, 5, 6 line. So ls output is going to wc and it is counting the lines. Normally ls output is coming where?
Terminal.
At the terminal, standard output, no?
Yes, sir.
Okay. So what is happening here? Output of ls is getting piped or transferred to wc. And these two programs are different programs. These two, actually, when they execute, these two will be different processes. Yes or no?
Yes, sir.
So wc is different executable. When you want to execute wc, that would be a different process, and ls is a different process. So what literally is happening here, that a process is giving its output as an input to another process. Am I right?
Yes, sir.
Okay. So this is a pipe symbol, pipe, and this is achieved by a pipe system call. So there is a pipe system call, there is a named pipe system call, and there are a lot of other techniques which help you to make processes communicate with each other. Here what is happening? A process ls is communicating with process wc through a pipe, and pipe is a system call here which provides you this environment that okay, ls output can be transferred to wc input and we can get the combined result. But there is a small catch here. If you use pipe, the process which are having parent and child relation, only those can communicate. If you want to have communication between unrelated processes which are not having parent child relationship, then you have to use a special pipe known as named pipe or FIFO, first in, first out. And there are lots of other techniques using which you can have communication and which we'll be seeing later on in our course. Message queues, signals, semaphores, there are a lot of shared memory, there are a lot of other techniques. More on them later. And I wanted to demonstrate the fork, exec and everything. That's why I have chosen this example. Now, what is a pipe? So before going into the pipe, let me explain certain things to you. And let me open my whiteboard for that. Present whiteboard is visible?
Yes, sir. Yes, sir.
Now, in our Unix, like OS, everything is a file. Everything is a file. So there are different kinds of file, as you might have seen in your shell programming course. I don't know whether somebody has taught you or not. So if you want to deal with device, printer, hard disk, anything, these are device files. If you want to deal with monitor, it's a standard output file. If you want to take input from keyboard, it's a standard input file. Everything is a file. And your user file and system files. Some files are there on hard disk. Some files are created in memory only, spatial files. We'll come back to these issues later on when we'll see file system. But here it is important to mention. Now, the way we have process ID to uniquely identify a process, we have a process ID. Similarly, to uniquely identify a file, we have file descriptor. Now, what actually is happening, I'm just telling you in very brief manner that operating system maintains a data structure known as file table. And this file table is having this index. Means row 0, row 1, row 2, row 3, row 4. And this index is actually your file descriptor. So whenever you want to create a file descriptor will be assigned. And depending upon the number of file descriptor, your entry will be made in the file table. This is done by operating system. So index to this file table is the file descriptor. First of all, try to understand this. Whether it's a standard output file, standard input file, device file, printer, whatever, everything is a file. And you know there are different types of file, block file, character file, and all that. Now, what is pipe? What is pipe if we want to see pipe? As I was telling you that everything is a file in Unix, user file, system file, device file. Files, as I told you, are indexed to the file table. Common file descriptor, standard input is 0, standard output is 1, and standard error is 2. So a standard input file would be always given file descriptor 0, standard output file would be given file descriptor 1, standard error file will be given file descriptor 2, and so on. You have used input output in C, and you might have used this particular thing, file, pointer, and you have used this fopen, fclose, fwrite functions. These functions are from stdio.h library. But as I told you that these functions finally use system calls, operating system routines like open, create, close, and write to achieve the desired effect. So to play with the file, we have these system calls: create, open, close, write, etc., etc. So when we use open system call, you haven't used it, you have used fopen, but fopen in its code uses open system call. So when we use open system call and the file is not created, the file will be created and a file descriptor will be written. So whenever we use a open system call and if it is not created or a create system call, so a file descriptor will be written. Entry is made into the file table and a file descriptor will be written to the program. So every file is identified by file descriptor. To know about that file owner permission, what is that? You have to go to this file table, index it with the file descriptor and see the details. This is what is happening in file system module of operating system. Now let's see what is pipe. Pipe is a spatial file. A spatial file. And this pipe is having two file descriptors. So whenever you use pipe system call, you will get two file descriptor. Array of file descriptor, and that array, the size of array is 2. FD0, which represents the read end, and FD1, which represents the write end. So when you use pipe system call, it creates a spatial file and returns two file descriptor, one for writing, another for reading. Now let us see whether we can write a C code which can give the same output the way we have seen ls pipe wc minus l, whether we can write a C code which can give us the same output. And those who are sleeping, please wake up. It's very important to understand this. And if you want to ask any question at this point of time, you can ask. Okay, so let's see that. So I have written a code here. Present code is visible?
Yes, sir, but it is not readable.
अब font कैसे बढ़ता है?
ये सर इधर प्रेफरेंसेस में बढ़ जाएगा.
कहाँ पे?
कौन से? ये टेक्स्ट एडिटर लिखा है सर, उस पर क्लिक करेंगे. यहाँ पे प्रेफरेंसेस होगा, उसके अंदर सेटिंग होगा, खुल जाएगा, उसके अंदर फॉन्ट बढ़ जाएगा.
यहाँ पे
प्रेफरेंसेस आया था ये.
हाँ ये है यहाँ पे. उधर है, टेक्स्ट एडिटर में नहीं है. फॉन्ट हाँ ठीक है. अभी ठीक है ना?
Yes, sir. Yes, sir.
So what is happening in this code, you can see I've declared a integer array of size 2. Then I have used a pipe system call. Then this parent process I have used fork. Now what will happen? Return will be transferred to the kernel. Two processes will be created, and depending upon the return value from fork, I have written two codes. So if return is equal to 0, this is child, else this is parent. Now please be with me and concentrate. So what we have started, declared a array of 2, integer array of size 2, used pipe system call, use fork system call, and depending upon the written value, we have written code in child and parent. Now in child, because it is written equal to 0, what is happening? I'm using a system call close with argument 1. So what will happen if I write close, if system call close with argument 1 is executed? So what will happen in file table? This file at file descriptor index number 1, which is normally for standard output, std out. So file descriptor 1, this file will be closed and this descriptor will be freed. So I'm using close 1, I'm closing standard output. Okay? This is what that particular line is doing. Can move ahead. Next line, I'm using another system call, which is dupe system call. When dupe is used, what will happen? From top to bottom in file table, whichever FD is free. So here we have already freed standard output FD1, will be duplicated in the argument of dupe. So here what we have done, we have freed the FD1 and just after that we have used dupe. So whatever FD which was freed here, because we have closed FD1, so that one will be duplicated in the argument of dupe. And what is there in the argument of dupe? FDS1. And what is FDS1? The right end of the pipe. Abhigyan, got it?
Yes, sir.
Shall I explain it again?
Yes, sir. One.
Okay. So just see the code. In child process, I've used a system called close with argument 1. So normal standard output will be closed. Then I have used dupe. So because I have closed standard output in the previous line, when I use dupe afterwards, so whatever argument of dupe is, whatever free file descriptor is, that will be duplicated here. So in effect, standard output would be duplicated as one end of pipe. And which end of pipe? Right end of pipe. This is what is happening here. Now in child process, I'll close the another end because child process does not need it. And then what I'm doing in child process, I'm using exec and running ls. It's a variation exec lp where you can just give the command name directly. You can go and read the variations of exec lp, exec v and all that. So I'm repeating it again. Closing the file descriptor 1 means closing the normal standard output. duplicating the standard output to one end of the pipe, closing another end of the pipe because child does not need it, and then executing ls within child means the image of child process which has been created by parent is destroyed. A new image will be created that will be image of the ls. So what in effect is going to happen when child executes? What is going to happen? Child executes ls and will write the output instead of standard output to this end of pipe. You got the point? Instead of sending output to standard output, generally ls output will go to standard output, but we have closed the standard output, duplicated it with the one end of the pipe, and now the ls output will go to the one end of the pipe. This is what is going to happen in the child process when child process executes. Now what is happening in the parent process? If return value is not 0, then this parent will execute. What we are doing? We are closing the 0. And what is 0? 0 is our file descriptor for standard input. And then now you can guess, I will use dupe with another end of the file fd 0. So standard input in parent process will be closed and it is duplicated to another end of the pipe. Which end? Which end? The reading end. And in parent process, what I'll do next? Close the another end. Parent does not need that. What I'll do in parent process? I'll execute WC with argument -L. So in effect, what is happening? Generally, WC, if you don't give anything, will take input from the standard input. Here, WC is going to take input from the another end of the pipe, this end, FD0, because we have used dupe, close the standard input and duped it with FD0. So now WC minus L will take input from FD0 end. So now you can get what is happening. Whatever is the output of LS will go in pipe, will come from the another end and will go into WC minus L as input. So at one point of time, I have closed standard output and duped with the another end of pipe, one end of pipe. Another time, close standard input and duped it with the another end of the pipe. Now let's run this program and see whether we can get the same effect. See, it is giving me the same output. ./a.out in this directory is given 7. Let's see what it will give. 7. So what we have done, we have written a C program for this particular command, shell command, by using this system calls close, dupe, exec. Any doubts to anybody? Yes, Brajendra?
ये सर ये फाइल टेबल के साथ क्या हो रहा है? फाइल टेबल सर अलग अलग होता है या शेयर्ड हो जाता है प्रोसेस?
I'll come back to this later with you. Actually, uh, there is open file, system-wide open file table, then per process file table. So I don't want to again get into the details of that thing. We'll see.
Okay, sir. I got that.
You know, I think getting the idea. It's a system-wide file table and then
Yes,
per
sir.
process file table.
Okay,
Actually, that is related with, I think if you remember, that is related with the inode table.
yes, sir.
In cache, in memory inode table, and then file
Yes,
table.
sir. ये memory में. Yes,
You got the point?
yes, sir. Yes.
Okay, okay. So I didn't want to confuse these students because they don't know about the files. I just wanted to demonstrate them the pipe thing. Yes, any questions? Aman? Aman Singh?
No, sir. No question.
Got it?
Yeah.
Now, let's see the last topic of today. Suppose I want to communicate between two processes which are unrelated. Between two processes which are unrelated. Here, pipe can only be used when you want to have communication between parent and child processes. There you have seen that LS and WC minus L both are the processes sharing the parent-child relationship. Now, if you want to have communication between two unrelated processes, then there is another inter-process communication construct known as named pipe. But before going to named pipe, let me tell you certain things. Now, pipe, even if it is a file, it is not listed. As soon as your work is done, the pipe is destroyed. It is not having any name. It's a spatial file. Now, if you want to have communication, then obviously you have to share this unnamed construct between parent and child, then only the communication can take place. Now, if there are two processes, P1 and P2, which are having no relation, you require something with some name or identity so that P1 and P2 can both communicate through that. So for this purpose, we have another spatial file known as named pipe or FIFO. FIFO means first in, first out. Whatever you have, you will write first, will be outputted first. So what you can do when you create, I'll tell you the system call for creating FIFO. When you create a named pipe, process P1 can refer this pipe with its name and write, and process P2 can again refer to this name and read. This is what is named pipe, a little bit different from the normal pipe. Now, to create a named file, Okay, if I show you my desktop, let us see any file. Suppose there is one file. And if I right click this and go to the properties. So hell lot of properties are there when it is created, when it is modified, when it is accessed, what is a program which can open this, where is this location, what is the size, then security related, other details, whether any previous version is there or not. Can you tell me where all these information in files are stored? Can go and right click the see the properties. Yes, Aman? Because you have just created a doc file. Aman?
Sure.
Where these information about any file is stored? These information I'm talking about. Suppose I go and right click any file and see the properties. So these information, where is the location, size, when it is created, who modified that, when it is modified, where it is stored in any file. Yes, Anchal Tiwari.
Yes, sir.
Any guesses?
So, no, sir, but sir, maybe, no, sir, not really. I'm not sure about it.
And for that sake, every file is having that. Yes or no?
Yes, sir.
Well, it's a PDF file. Suppose I check a PPT file. Again, you can find this information. Name, modified, date modified. So as a matter of fact, every file, there's one thing which is data inside the file. And in addition to that, every file is having metadata, data about that data. So if you go in Windows type of operating system, this metadata storage is known as file control block. That every file is going to have a attached one attachment, that is file control block. If you go to Linux and Unix family operating system, it is known as inode, information node. So whenever any file is there, or a special file, device file, or any file which is having any name or existence, that is going to have a inode. It's known as information node. And this information node stores all the information. Information node stores all the information. एक बात बताओ यार तुम लोग, अमन, अभिज्ञान,
Yes, sir.
you have done shell programming, no, in the last semester?
Yes, sir.
You have done hard linking, soft linking, all those things?
No, sir.
How to create a hard link to a file, soft link to a file?
No, sir. We have not done that.
What you have done in shell programming?
So the basic commands of cat and like all the commands and file system we had also done.
Mm-hmm.
basic.
Mm-hmm.
Yes, sir. That.
Have you heard this term before? inode.
No, sir. I know that not.
So what file system you have done? Tyagi sir?
मैंने नहीं पढ़ा है भाई ऐसे पूछ रहे हो क्या पढ़ा है मैंने कहा भैया मैंने नहीं पढ़ा है
नहीं, मैं जानता हूँ आपने नहीं पढ़ाया सर। आपने पढ़ाया होता तो
पता नहीं तब भी ऐसे ही बोलते हैं क्या है मैं तो बहुत बार अपने कोर्स में पढ़ा के नेटवर्किंग में पढ़ा के सुन चुका हूँ ऐसे है जवाब पता नहीं किसने पढ़ाया anyway
even I don't know who was taught. Anyway, that's another story. So anyway, so what I was telling that there is a inode with every file. Please mute. Somebody has unmuted. So, and when we want to create a file, the first thing is a inode has to be, I'm using a term created, but it's not a right term here. Actually, inodes are assigned when you create a file. And when you destroy a file, inodes are reclaimed by file system. But just in a simple term, I'm saying that whenever you want to create a file, a inode has to be created. In reality, inode is assigned, and when you delete a file or destroy a file, the inode is reclaimed. And as I told you that FIFO is going to be named.
Mayank,
Sir.
एक तो ये कोर्स में मेंशन है मेरे ख्याल से शेल प्रोग्रामिंग के कोर्स में मेंशन है तो क्या राशि की बात थी थोड़ी सी लेकिन ये मेंशन है कोर्स में और अगर किसी ने नहीं भी पढ़ा है तब भी इन लोगों को एक जनरल क्यूरियोसिटी तो होनी चाहिए ना जब आप पढ़ रहे हैं जब आप देख रहे हैं फाइल है तो आपको ये तो पता होना चाहिए कि भाई क्या हो रहा है किधर है फाइल क्या है इसके अंदर अब आप केवल कहें कि साहब किसी टीचर ने वो नहीं पढ़ाया इसलिए हमने नहीं पढ़ा ये कोई बात नहीं है क्योंकि कोर्स में जो है वो एग्जाम में हमेशा ही आ सकता है आपने क्लास में पढ़ा हो या ना पढ़ा हो उस हिसाब से भी इन्हें पढ़ना चाहिए था बट क्या करें और जनरल क्यूरियोसिटी भी है कि भाई आप अपना देख लीजिए लेकिन अब बिल्कुल ही हैंड टू माउथ रहो तो क्या करा जा सकता है
एकदम सही कह रहे हैं सर आप और उसमें क्या होता है इन लोग को समझ में नहीं आता है कि सिलेबस और कोर्स करिकुलम डिसाइड ही ऐसे किया जाता है कि चीजें पहले सेमेस्टर में कुछ फिर नेक्स्ट सेमेस्टर में जैसे सीओ पहले पढ़ाया गया फिर शेल प्रोग्रामिंग भी चली फिर ओएस चल रहा है सो वो एक फ्लो बना रहता है एनीवे सर क्या करेंगे सो लेट मी डू माय जॉब सर anyways so as I was telling you so whenever a named entity spatial file like FIFO and everything is created you have to create a inode and as I told you inodes are assigned. So what is going to happen if you want to have communication among two processes which are unrelated you need to first of all create a pipe and to create a pipe there is a system called known as make node. We'll see the arguments of this make node. And using make node, you can create a named pipe. And this named pipe can be utilized by unrelated processes P1 and P2 for the communication. So let's see the code of make node and named pipe. And let's see whether two unrelated processes can communicate or not. So suppose I want to have communication between two process. One is speaker, another is listener. One process will keep on writing on terminal, another process will keep on reading on the terminal, another terminal obviously. So this is our speaker.c file. Here I have defined FIFO name as my pipe. Fine. And this is your make node command. When you saying make node, the first argument will be the name of the FIFO, name of the pipe. Then you are telling make node command that it is going to be FIFO. Then this is the permission. अभिज्ञान
Yes, sir.
अभिज्ञान
Yes, sir.
CH mode क्या होता है?
I don't remember.
Anybody know about this CH mode? Aman?
No, sir.
So
सर
you
फाइल परमिशन
सर
के लिए
जो
होते हैं।
Yes, sir. File permission.
फाइल परमिशन के लिए क्या होता है? फाइल परमिशन में क्या डालते हैं अपन?
सर
जो
ग्रुप
सर
का होता
रीड
है।
राइट एंड एक्सेस करने का जो परमिशन
हाँ भाई,
मिलता है।
don't give me shocks, no, that you don't know about this. Fine. It's a permission group, owner, user, no?
Yes, sir.
Read,
Yes.
write, execute. Okay. And then there are these are octals, and in this way you can set the bits. Okay. So here I'm giving some permission to this FIFO. Fine. You can go and see later on. Now, then after creating the node in speaker.c, I'm opening this file. After creating a file, FIFO, I'm opening this file because once it is created in write only. So this is open system call argument. Which file? FIFO name, which has been created. What is the FIFO name? It's my pipe. Okay. And we are creating it in write only manner. And then I'm writing it. I'm writing into this file descriptor. Fine. While जब तक कि स्टैंडर्ड इनपुट का एंड ऑफ फाइल ना हो जाए तब तक कीप ऑन टेकिंग द कैरेक्टर्स एंड keep on writing it. If you are not able to write and it is number of written characters are negative, then it is a error. Otherwise, whatever you are writing will be written into this FIFO, which is opened in a write only mode. Okay, this is our speaker.c. Now let's see the another file listener.c. In listener, I'm using the same FIFO, make node, opening this FIFO in read only mode, and whatever I'm reading is getting printed. Do keep on reading from the file while number is not greater than 0. तो कब तक पढ़ते रहेंगे? जब तक नंबर हमारा नंबर ऑफ कैरेक्टर नल नहीं हो जाएगा. So this is what is the speaker file. Now let me run it. Let me run it. Let me open two new terminals. So let's suppose let me run speaker.c, GCC. Some warnings are there, don't worry. So this is a speaker file I am running. So right now there is no reader. That's why it is blocked here. In the speaker.c code, it will be blocked there. It is waiting for readers. Let me open another terminal and run now. Let's see what will happen. Waiting for writers. अभी राइटर ऑलरेडी अपन चला चुके थे और इधर देखो क्या हुआ. Now we got a reader. Type some stuff. तो जब तक रीडर नहीं था, it was waiting for reader. As soon as reader is there, it is also dealing with the same. And one more thing, if you see carefully, let me open another terminal. And if I do ls here, you see here, this is a special file which is created, MyPipe. And this MyPipe was the name of the FIFO in our code. Got my point? So this particular named pipe is having its existence. Now let me write something here. Hello. And let's see what is happening there. I have written 10 bytes. What listener will do? Okay, listener had read 10 bytes. Hello. Suppose I write something, how are you? Listener will get, how are you? So beautifully what you have done, there are two different processes. And you can assume these are producer-consumer process also. A producer is producing data item and consumer is consuming data items. And with the help of the named pipe, two unrelated processes are able to communicate. So this is what I wanted to tell you before embarking upon the actual XV6 code, which we are going to take in the next lecture and in our lab classes. We'll be seeing the internal codes of fork, exec, and all that. That fork code is also written in C. So how fork creates two processes and return two values, everything we are going to see later on in our XV6 code. If there are any question, you can ask. Otherwise, I am done for today. Bridget, any question?
No, sir. No, sir.
Any other question from anybody? You have system programming lab this semester, no? Aman Singh? Programming tools 2 is system programming.
Yes, sir.
And the things which I have taught today and up till now are part of that system programming lab. Got the point?
Yes, sir.
So take the thing seriously. Otherwise, you people will be computer engineers by name only. You will not be real computer engineers if you don't know about the systems. Be it a computer organization, be it shell programming, Linux boxes. You need to know the Linux box. You need to know how actually system is working. Otherwise, you'll be called as computer engineers, but in reality, you'll not be. Anyways, thank you.